Welcome back to an exciting day in Algebra 2. We have been talking about systems of equations, and now we are going to move on to systems of inequalities. Remember, this is your greater than or less than symbols. So first, we're going to touch on what a solution means. In an ordered pair, x and y, a solution is it's a solution to the system of linear inequalities if when you plug that x and y into both inequalities, it is true. So if I'm looking at this inequality system here, 2x minus y is less than or equal to 5, and x plus 2y is greater than or equal to 2, I have to plug this set of xy pair into both inequalities and see if it's true. So starting with 2, 4, I'm going to plug that into the first one. 2 times 2 minus 4 needs to be less than or equal to 5. Well, 2 times 2 is 4. 4 minus 4 is 0. 0 is less than or equal to 5, so that's true. Now if I plug it into the bottom, 2 plus 2 times 4 needs to be greater than or equal to 2. Well, 2 times 4 is 8, and 8 plus 2 is 10. This is also true, so yes, I can say this is a solution to that system. On the next one, 0, 0, if I plug that into the top one, I get 2 times 0 minus 0, which is 0. 0 is less than or equal to 5. If I plug it into my second inequality, I end up with 0 plus 0. 0 is not greater than or equal to 2, so this one is not a solution. On the last one, 0 and 1, if I plug that into my first one, I end up with 0 minus 1, and negative 1 is less than or equal to 5. If I plug it into the second inequality, I end up with 2, and that is greater than or equal to 2, so that one is also a solution. Okay. Another skill you're going to be expected to have in this unit is writing an inequality from a situation. So if your budget requires you to earn at least $160 per week, you work 2 part-time jobs. The first job pays $10 per hour, and the second job pays $8 per hour. It tells us to let x represent the number of hours worked at the first job, and to let y represent the number of hours worked at the second job. So our variables are already defined for us. We need to write an inequality that represents the number of hours worked at each job in order to meet your budget requirements. Well, job 1 pays me $10 an hour, and we are already told to let x be the number of hours we worked at that job. My second job pays $8 an hour, and I am told to let y be the number of hours I work at that job. So together, I need this to be at least $160 per week. So that means greater than or equal to 160. If I make more than 160, that's great, but I cannot make any less than 160. Okay, if the drama club is selling tickets to their play to raise money for the show's expenses, each student ticket sells for $4 and each adult ticket sells for $6. The auditorium can hold at most 107 people, and the drama club must make a minimum of $560 from each ticket sale to cover the show's cost. If 71 adult tickets were sold, determine the minimum number of student tickets that the drama club must sell in order to meet the show's expenses. Okay, there's a lot to unpack here, but let's just first start with writing our system. And this one is going to have 2 inequalities because I have 2 restrictions. I have a restriction on how many people can be in the theater, and I have a restriction on how much money I need to make from these sales. And this one does not define our variables for us, so we need to do that. I'm going to let x be the number of adult tickets, and I am going to let y be the number of student tickets. So if the auditorium can hold at most 107, then that means the sum of x and y, my 2 different types of tickets, has to be less than or equal to 107. I can sell out the show, but I cannot sell more tickets than I have seats. If the drama club must make a minimum of $560 from ticket sales, then that means that $4 for every student ticket, which I was letting be y, and $6 from every adult ticket, which I was letting be x, needs to be greater than or equal to 560. I can make more than that, but I cannot make less than that. So here is my system, and what we're told is that if 71 adult tickets were sold, Determine the minimum number of student tickets that the drama club must sell in order to meet the show's expenses. So if I am putting adult tickets at 71, that means 6 times 71, I am making a total of $426 from the adult sales. Well, if my goal is to get to 560, that means that I need a remaining, if I just subtract these two numbers, $134. Now that $134 is going to come from student sales, and I sell those for $4 a piece. So if that's equal to 4y, dividing both of those by 4, I get, and it's 33.5, which means I need to sell at least 34 student tickets. So this is my system of inequalities, and then I need at least 34 student tickets to meet our minimum expenses. Okay, let's talk about graphing. This is similar to graphing lines, but we have some other rules. When we do not underline our inequality, we graph it with a dashed line, and when we do underline the inequality, it is graphed with a solid line. If it's greater than, you're going to shade above, and when it's less than, you're going to shade below. So you're still going to look at your slope and your intercept to find your line, but we are following these new rules for dashed / solid lines and shading. So we're going to do two examples. The first one being Peyton and her children went to a restaurant where they sell drinks for $3 each and tacos for $4 each. Peyton has $40 to spend and must buy at least 10 drinks and tacos altogether. So to write this system, I first need to define my variables. We are going to just go back to our basics, x and y. And what we're looking at is items. So I'm going to let x be the number of drinks, and I'm going to let y be the number of tacos. So I know she has $40 to spend. So if drinks are $3 each and tacos are $4 each, that total cannot exceed $40. So it needs to be less than or equal to 40. And then I also know that she must buy at least 10 items altogether. So that means x plus y has to be greater than or equal to 10. So in order to graph these, though, I need these equations, I need these in my slope-intercept form, which means I need y by itself. So for the first one, in order to make that happen, I need to subtract 3x. And so that ends up looking like 4y is less than or equal to negative 3x plus 40. And I'm almost there, but I still need this to be y. So I'm going to have to divide everything by 4, which means my final inequality is y is less than or equal to negative 3/4 x plus 10. Now I know my intercept and I know my slope. On the second one, this one's a little easier. I just need to move the x by subtracting it. And so that one is that y is going to be greater than or equal to negative x plus 10. So now we need to get each of those on our graph. I'm going to do the first one in pink. So I know my y-intercept is up here at 10, and my slope is negative 3/4. So that means I'm going to go down 3 and over 4. Down 3 and over 4. Wait, I didn't go over enough that first time. Come on. There we go. And now down 3 over 4. Down 3 over 4. And then that will take me off my graph. Let me connect those dots. And this inequality is underlined, so that means it's going to get a solid line. And I'm going to now look at my shading. This says less than, so that means my shading needs to be below. So everything underneath that pink line. Okay, I'm now going to graph my other one in blue. This one also starts at 10. I have a y-intercept of 10, but my slope is negative 1. So down 1 over 1, down 1 over 1, on, and on, and on. And this one also gets a solid line because our inequality is underlined. And again, this one is now greater than, so that means I'm going to be shading above. So everything above that blue line gets shaded. So there's my graph. How do I determine two pairs that are in my solution? This is different from your systems of equations where you had one answer, because here, anything that is in where my shadings overlap, so anywhere where I ended up with, purple, where I have pink and blue, any points in here or on those lines, because they are solid lines, can be part of my solution. So all I need to do is find 2 points that are in here. So here, 10, 1 is a potential solution. Or let's see another one, 8, 3 is another solution. And we know that we can check this by plugging back into our 2 inequalities to see that they both work. So for 10, 1, for example, if I plug that into the first one, 1 is less than or equal to negative 3/4 times 10 plus 10. Well, negative 3/4 times 10 is negative 7.5. Negative 7.5 plus 10 is 2.5, and that is greater than 1. Now if I plug it into the second equation, 1 is greater than or equal to negative 10 plus 10. Well, negative 10 plus 10 is 0, so that does work. Now let's test our other solution. If I plug 8 and 3 into the first inequality, 3 needs to be less than or equal to 3/4 times 8 plus 10. Negative 3/4 times 8 is negative 6. And negative 6 plus 10 is 4, which is greater than or equal to 3. On the next one, 3 needs to be greater than or equal to negative 8 plus 10. Negative 8 plus 10 is 2. 3 is greater than or equal to that. So both of these solutions are valid. And let's talk about what they actually mean. Remember, X was our number of drinks and Y was our number of tacos. So one potential solution is that she buys 10 drinks and 1 taco. Another possible solution is that she buys 8 drinks and 3 tacos. And there are many, many more possibilities. You just need to find points that are within where our shaded regions overlap. Okay, we are going to do one more example. Ariana has X nickels and Y pennies, so our variables are already defined for us here. And having no more than 20 coins worth a minimum of 40 cents combined, at least 10 of the coins are nickels. Solve the system of inequalities. So together she has no more than 10 coins. So that means X plus Y has to be less than or equal to 20. And they're worth a minimum of 40 cents. Well, we know nickels are 5 cents and pennies are 1 cent. Together they need to be a minimum of 40 cents. So greater than or equal to 40 cents. So there are my 2 inequalities that I am going to need to solve. Graph and solve. Now this one is saying at least 10 of the coins are nickels. So this is going to come to play when I look at my graph and my potential solutions. But our first step is going to be to get this in on the graph. So first we need to rewrite each of these inequalities so that we can see the slope and the intercept. And I'm running low on time, so I'm going to continue this in a second video.